Hello, bachcho. So let's see this question. If 3 times of sine beta is equal to sine of 2 alpha plus beta, then tan of alpha plus beta minus twice of tan alpha is independent of alpha. Option B is independent of beta. Option C is independent of both alpha and beta. And option D is independent of alpha but dependent of beta. So ऐसे तरह के प्रॉब्लम्स में मेजरली हमें साइन थीटास जो भी दिए गए हैं उन्हें हमें टैन केस में ले जाना पड़ेगा या तो फिर टैन ऑफ अल्फा प्लस बीटा को साइन केस में कन्वर्ट करना पड़ेगा ताकि हम इवेल्युएट कर सकें। तो पहले तो हम इस क्वेश्चन के अंदर कंसेप्ट लिस्ट कर देंगे जो भी हम इस प्रॉब्लम को सॉल्व करने के लिए यूज करेंगे। द की कंसेप्ट्स इन्वॉल्व्ड आर बेसिक ट्रिगोनोमेट्रिक आइडेंटिटीज and the trigonometric identities that we'll be using is sine of 2 theta is equal to twice of sine theta times cos theta. Another trigonometric identity that we'll be using is cos of 2 theta, which is either 2 cos square theta minus 1, or this can also be written as 1 minus 2 times of sine square theta. And the third trigonometric identity that we'll be using is sine of a plus b. Here a and b are angles, and this comes out to be sine of a times cos of b plus cos of a times sine of b. The last identity that we'll be needing is cos of a plus b, which is cos a times cos b minus sine of a times sine of b. The other thing that we'll be using will be basic things like sine theta upon cos theta equal to tan theta and such. Now, move on with the problem by listing the things that has been given to us, which are given 3 sine beta is equal to sine of 2 alpha plus beta. Now, using the sine of a plus b equal to sine a times cos b plus cos a times sine b identity, I'll split the RHS and we'll obtain this as sine of 3 times sine of beta is equal to sine of 2 alpha times cos beta plus cos of 2 alpha times sine beta. Now, we see over here that we have sine of 2 alpha and cos of 2 alpha. So, we'll manipulate them using the identities sine of 2 theta equal to 2 sine theta cos theta and cos of 2 theta as 2 cos square theta minus 1 or 1 minus 2 sine square theta. Now, the basic idea is to obtain a favorable expression so as to evaluate our given expression. So the first thing I'll be doing is I'll be substituting this cos 2 theta with 2 cos square theta minus 1 and sin 2 theta with 2 sin theta times cos theta. So we obtain this as 3 times sine of beta is equal to 2 sin alpha cos alpha, and alongside this we have cos beta plus, and this cos 2 alpha we'll rewrite this as 2 times cos square alpha minus 1 times sin beta. This becomes as 2 sin alpha cos beta plus 2 cos square alpha sin beta minus sin beta. This is equal to 3 sin beta. I'll bring this sin beta of the RHS into our LHS and we'll see this as 4 times sin of beta is equal to 2 times sin alpha cos beta plus 2 cos square alpha sin beta. On the two terms on the RHS, we have cos alpha as common in both of the terms, 2 cos alpha. So this becomes as 4 times sin beta, and we'll take 2 cos alpha as common, and we obtain sin of alpha times cos of beta plus cos of alpha times sin of beta. Now this reminds me of an identity which is sin of a plus b, and where a would be alpha and b would be beta. So we obtain this as 4 sine beta times 2 cos alpha, and this will be rewritten as sine of alpha plus beta. Now I'll send this 2 cos alpha on the LHS so as to evaluate only the value of sine of alpha plus beta in terms of sine beta and cos alpha. And I'll obtain this as sine of alpha plus beta is equal to 2 sine beta upon cos alpha, which is the first thing that we'll be needing in the problem. The second thing that I can do with this given equation that we had seen earlier is to replace this cos 2 alpha by 1 minus 2 sine square alpha instead of 2 cos square alpha minus 1, and using 1 minus 2 sine square alpha in place of that, we'll obtain 3 times sine beta is equal to 2 times sine alpha cos beta minus, rather, plus 1 minus 2 sine square alpha times cos beta, rather sine beta. And this becomes 2 sine alpha cos beta plus sine beta minus 2 sine square alpha sine beta. I'll bring this sine beta on the LHS where we have sine 3 times sine beta, and this becomes 2 times sine of beta is equal to 2 sine of alpha cos beta minus 2 sine square alpha sine beta. And we have 2 sine alpha as common both the terms on the RHS. So we, uh, we simplify this as 2 times sine beta equal to 2 times sine alpha times alpha cos beta minus sine alpha sine beta. And this cos alpha cos beta minus sine alpha sine beta ये लिखा गया है 2 times sine alpha times cos of alpha plus beta. और इस cos of alpha plus beta कोई अगर मैं ऑब्टेन करना चाहूँ तो मैं क्या करूँगा, 2 sin alpha जो है RHS के अंदर उसको मैं LHS में लेकर आऊँगा, and this becomes cos of alpha plus beta is equal to sin beta upon sin alpha. अब मेरे पास sin of alpha plus beta की वैल्यू है, cos of alpha plus beta की वैल्यू है, सो मेरे पास सिंपली स्पीकिंग tan of alpha plus beta की भी वैल्यू होगी बाकी टर्म्स के इसमें. और अगर मैं इवेलुएट करूँ tan of alpha plus beta को तो बनेगा 2 times sin beta upon cos of alpha upon sin beta upon sin alpha. This becomes tan of alpha plus beta equal to sin beta कॉमन है, एंड RHS को हम सिंप्लीफाई करके हमें क्या मिलेगा, 2 times sin alpha अपॉन cos alpha. अपॉन cos alpha tan alpha होता है, तो ये बेसिकली लिखा गया है 2 times of tan alpha. अब जो हमें एक्सप्रेशन इवेल्युएट करना था वो था tan of alpha plus beta minus 2 tan alpha. Expression to evaluate was tan of alpha plus beta minus 2 tan alpha. और क्योंकि हमने सिंप्लीफाई किया है tan of alpha plus beta को 2 tan alpha के इक्वल, तो हमें मिलेगा ये जो एक्सप्रेशन होगा वो बन जाएगा 2 times tan alpha minus 2 times tan alpha, which is of course 0. Hence our final answer will be 0 बन जाएगा, which is independent of everything else, which means that it is independent of beta, it is independent of alpha. Hence our final answer would be option A, independent of alpha, and option B, which is independent of beta. I hope you all understood it well, and best of luck.